Good evening, Ajay and Babura. Okay, Vagesh, tell me the number.
14, 15, 16, 29.
14. Okay. Which of the following is most appropriate thing to do during the planning process group? Look for any problem incident and that may impact project in future. Update the schedule based on late deliverables. Increase the effectiveness of process. Review business case to justify the investment in the project. You probably might have ticked D. Okay, see, look at the question. Which of the following is most appropriate thing to do during planning process? So we are talking about planning process. Means we are not in execution. So if you see B and C, they are actually execution. Update the schedule based on late deliverable. Update will come once the execution is start. Increase the effectiveness means current effectiveness is not good, means you are in execution. So B and C are ruled out.
Yeah.
Now only A or D could be possible, because look for any problem incident that may impact project in future. That is one thing. And review the business case to justify the investment in the project. Now if you see, D is more appropriate at the initiation. We are talking about preparing a charter, or maximum we can say about the scope statement. When we say justify the investment, means we are talking about preparing a charter. Right? The business case is most important at the time of starting the project, which is initiation, and initiation talks about business case.
Okay.
So if you see what we do, what is planning? Planning is basically looking into the future and preparing for it.
Yeah.
And therefore A is the most appropriate one. So even if I consider that D could be a part of scope statement also, then even if I have to select one, either of A or D, then I will prefer it.
In some that course material, it was also mentioned that in planning process group activity, it sometimes required review the business case to justify the investment. It's also applicable, but here the most appropriate, it looks that the option A, and where I got confused between A and D.
Yeah, that's quite obvious that I'm saying that the D could be a part of the planning process also. But in this case, if I have to choose one, the primary intent of planning is actually A. What is the intent of planning? The intent of planning, hello, are you getting me? Hello? Hello, are you getting me?
Hello, I'm not able to hear you. Hello? Yeah, right.
Okay. Yeah, so I think there was some disconnect of the voice.
Yeah.
So here, if you see, if I have to choose one, the main intent of the planning process is to deal with future, not to justify the investment.
Yes.
What is the intent of the planning process? Intent of the planning process is to prepare for the future.
Correct.
Not to justify the investment. That is the primary intent. Yeah. So if I have to select between A and D, I will select A.
Yes, yes.
Can I say something?
Yeah.
Now, what you are saying is, if we are reviewing the business case in the starting itself, that also means that we are planning for the future, no? Isn't it?
Justifying the investment is see, there are two things. One is you are looking for what can happen in future and then preparing for it. Second thing, you are justifying the investment. Investment means, is this project really required or not?
Correct.
Is it worth taking this project or not? You can validate in the various time in the project. And wherever it is not justifying, you can stop the project.
Correct.
You can look into future and say, is this really going to give us the results? But is this the primary intent of the plan?
Okay.
Why do we do plan? So that we can meet some eventuality in the future. If you are going from city A to city B, which requires considerable time, say 10 hours, will you plan the path, etc.?
No.
Right? You will say that, okay, from which city we should go. There are multiple options available to you. What you are trying to do? You are trying to find a most efficient way of reaching to the other city. The justification to the investment is already done for when you have taken up the work. I have to go to the other city. But something changes in the situation. There is some changes in the situation. You can revalidate your investment. But when you are revalidating your investment, it is not planning. Again, you are checking your objectives. I am going to meet my objectives or not. That is actually the part of overall goal of the project. It's not planning.
Planning process. Yeah.
So should that come into initiation? By initiating, then we can do that. Point number D, review the project, review the business case.
Absolutely. So it is actually initiation, but when the situation changes, you can revalidate it.
Done.
Right? You can always justify, just see the justification. Is it really making sense today? So many projects get abandoned and are stopped because it is no more make sense. It's possible. But that is not the intent of the planning process. Planning process, we can handle future incident better. That is what the real intent of the plan.
Got it.
Yeah. So let's look at the question number 15. The project manager is compiling lesson learned at the end of the project. What is included in lesson learned? See, what is lesson learned actually? We should understand what is exactly lesson learned. Lesson learned means there is something good or bad happening in the project. Every project sees some kind of good things, some kind of situations which are not so good. What is the lesson for us? What we should carry on.
Went wrong.
What we should carry on in the next project, and what we should not repeat in the next project. So what happens every time there is a variance, it gives an opportunity to document some lesson that why this variance has come. So if you look at this last status report, see, lesson learned at the end of the project means we are consolidating the lesson learned of all the lesson learned of the project. So it is not about just last report, it is about the complete project. Something happened in the beginning of the project that has to be documented. All the plan used in the project, not only just plan, but there are many other things. Customer communication. Yes, if something has gone wrong, then or something was very good, then Bhagesh, what you can do actually, you can keep yourself muted for till the time you are not speaking, because I'm feeling hungry actually by listening here.
Okay, okay.
Okay, so if you see the what is every variance actually give us an opportunity to document lesson learned and take this for the next project. So what we are talking about here is variance, their causes and action taken. These are the main items for the lesson learned. Lesson learned means something has gone wrong or something has really gone very good. It's a best practice we should follow, carry on, or is something which you need to stop in our upcoming projects. Correct? If I look at the question number 16, which of the following is most appropriate thing to do in the monitoring and controlling process group? Create work performance report, obtain sign-off of the product of the project, implement recognition and reward system, manage the team to ensure the timely delivery. So these two things are execution, C and D. Right? Implement means execution. Managing team is a part of execution. Managing team never comes in the controlling process. So either create work performance report or obtain sign off are two of the things. Now we are talking about sign off of not the deliverable but the product. If it is obtaining sign-off or acceptance on the deliverables of the project, then I can say that it could also be part of the monitoring and controlling process. But because it is saying obtain sign-off of the product, which normally happens in the closing process. So only thing left is the create work performance report. Make sense? You can unmute and speak and then mute yourself. Don't keep unmuted. That is when actually the background is voices start coming up. Any other? I think you're talking about 14, 15, 16. Any other one? 18. Okay. All of the following are typical concern of team members in a matrix organization. Except. So you talk about except means we are talking about which is not. Wondering who will do their present. Reporting to multiple bosses. Calculating the performance bonus due to working on multiple projects and communication is too complex to handle. See, I said matrix means if there is no adjective given, it means it's a balanced matrix. If it is not given weak matrix or strong matrix, it means it's a balanced matrix. Now, when we talk about matrix, the horizontal and vertically connected, like the I will say functional groups and the project group, they cross each other. So there are duality which come into picture. So if you say A, B, both talking about duality. The resource is coming from functional group and working in the project group. So he's reporting to the project manager as well as reporting to his original boss, who is actually part of the functional group. So there are multiple bosses. Because there are multiple bosses, there are more stakeholders in the project, definitely the communication is complex. That we have learned. Wondering who will do their appraisal, there is also a possibility, because the thing is that he is currently reporting to project manager, but once the project is complete, he goes back and report to functional manager. So there is a problem with this. So all these things are part of the matrix organization. The only thing which is not here, because calculating performance bonus is not the employee work. It's an HR work. Either HR or account, as mentioned in this account. Basically, who will do how much bonus is decided by HR or account. Any other one? Okay. Any other person who want to discuss any question? Should we start our time management? If there is no other question. So yesterday we saw that first we prepared the plan, schedule management plan. What was that? That we have to decide which tool we're going to use. What is the method of verify, like what is the project management tool we're going to use, the measurements, the unit of measurements, the precision, and all other things which are related to how we're going to manage our schedule, that is put into the schedule management plan. How we're going to identify our activities, the resource calendar, etc., who are available, who are not available, such kind of things. Now the next part was the first define the activities. So we have all the work package from the WBS. So we take every work package and identify which activity we need to perform, activities we need to perform to develop this work package. So we get all the activities and then we go to sequence them. We talk about finish to start, start to start, finish to finish. And we said that 80–90% are normally finish to start dependencies, and these dependencies will go to those slides. We talk about defining the activities like this. Right. And then we talk about defining dependencies, finish to start, start to start, finish to finish. We also talk about some mandatory and discretionary dependencies. We said in mandatory or external dependency cannot change, but discretionary we can take a decision. We want to do it in sequence or in parallel, and they can be re-evaluated if we want to compress our schedule, while mandatory dependencies cannot be re-evaluated. Then applying leads and lag, we also see that if whenever possible to save the time, we take leads on the dependency if possible. Like you are doing design and design is not complete, but when the design matures, you can start the development. You can start the construction of the building if you have a mature design, even though it is not approved or it is not complete. On the other side, we talk about that there could be a possibilities when the the previous task is completed, but successor still need to wait for to start, because there are some external dependencies or external circumstances which are imposing is to wait for some time, and we normally say it is lag, and that is idle wait time. So we on sequencing, we will get this kind of network diagram which will tell us which activity will happen at what time. Then we talk about that identify the resources and their quantity or availability of their. So we do some alternative analysis if the required resources are not available, to identify how we can how differently we can do this. We talk about bottom-up estimates and the softwares. So what we get is what resources are required for each activity and in how much quantity. Along with this, we estimate our duration, and then to calculate duration, we talk about analogous estimate. When we said about the previous, the one-to-one mapping of the projects, like we are estimating for a project, a similar project has been executed in the past, so we take their actuals as the input to as a base for the estimating the new projects. More the similarity, better the estimates are. On the other side, the parametric estimates are formula based, and these normally formulas are driven by the studying various projects in the history we have done, and then coming out with a looking at the pattern and coming out with a formula, and then using this formula to estimate our new project. This is normally comply with the regression estimate. So understanding various projects and then coming out with a formula is called regression analysis, looking at the pattern. And then we talk about 3-point estimate, that is PERT estimate, and we said instead of asking an expert the estimate, we talk about most likely. We ask him that give 3 estimates, most likely when when normal circumstances, optimistic when everything goes well, pessimistic when everything go wrong, and how much time it takes. And then based on these formulas, we estimate the duration, and we also calculate the standard deviation by looking at the minimum and maximum duration possible, and then it helps us to give us a range in which the project will finish. We did this exercise, and then we talk about develop schedule. And in developing schedule, we mainly talk about schedule network analysis, which are critical path, critical chain, resource optimization, adjusting lead and lag, and some schedule compression techniques. So yesterday we discussed about critical path. We also calculated critical path. We also discussed about the float, and we talk about that float is a free time available on an activity by which an activity can be delayed without delaying the project. It is called total float, and the free float means delaying the activity without delaying the next activity. Project float means an amount of time available at the end of the project. We also talk about a near critical path. A near critical path is the path which has a tendency to become critical. So on this path, the float is very low. So if 1 or 2 activity get delayed, the path will become critical. Okay, so this is the exercise we did yesterday. Now we talk about critical chain method. Mainly critical path which is used. Now when the critical chain come into picture, is critical chain is basically work on theory of constraint, which is actually given by Mr. Godhard, who wrote the book Goal. Now what is this? What is said that in a critical path we only talking about duration. Now if some activity which is not on critical path, but we have very niche resources required on that, and those resources are difficult to get, will that activity not be critical? So what we do, we on the critical path we apply the resource constraints and then we draw the critical path after like influencing it with the resource constraint. On this critical path, this new critical path is called critical chain. And then he suggests that keep some buffer in the project and distribute this buffer on throughout the project, so that not only project complete at the on time, but all the milestones should also be achieved on time. So it says that when there are a couple of rules which he has gave, that once put some buffer at the end of the project, put some buffer before major milestones, so that if there is some delay we can achieve milestone on time using this buffer, and add this buffer where a non-critical activity feed into critical path. A non-critical activity, like in this case, this was our critical path, right? Now here non-critical activity add to the critical path activity. Therefore we add some buffer here. So if this activity get delayed or some other activity, we are still on time. Add some buffer at the end. Add some buffer at some major milestone. If this is a major milestone, then put some buffer here. If this is a major milestone, put some buffer here before this, in this. So these are the things which are talk about critical chain method. And critical chain method is normally for a long time a similar kind of concept is being applied in the trains. You might have seen that in long distance trains, normally who are taking about 15, 16, 20 hours, they have major station in between, and you might have observed if you have traveled through trains of long distance, that sometimes train reaches at the major station and stand there for half an hour, 15-20 minutes, while it's supposed to stay there only for 5 minutes or couple of minutes only. And sometimes you think you saw that before you sleeping the train was running 2 hours late, but it reaches on time. The simple reason is that if this journey is 18 hours, the railway will give you this journey of 20 hours. So they will put half an hour here before the final station, maybe half an hour here, maybe half an hour here, maybe half an hour here. So every major station, before just major station, they have provided a half an hour extra time. So it may be 2 hours from here to here, but they have give you time after 2.5 hours. So if train runs well, then it reaches here half an hour early. When the train runs on time, normally the driver get instruction to go slow or maybe stand little bit before the station. So it reaches the station only 5-10 minutes before. If it is running late, then it continues going on and it reaches here. As soon as it reaches here, it gain half an hour. If it is running still good, then again it will gain half an hour. So by this time, it will cover about 1.5 hours. And if it is late by 1 hour, you will see it will reaching on time. So such kind of things we should also do in our project. But when we will be able to do, we will be able to do when we will prepare a good schedule and then distribute our buffers in the whole schedule properly and deliver every milestone and the project final deliverable on time. There are some resource optimization techniques which a scheduler normally provide, and one major thing provide is the resource labeling. And resource labeling is something like every resource can work 8 hours a day. So every day a resource can work 8 hours a day. But suppose there are two activities. Suppose there is a lead and the same person is working on both the activities. During this time, he will be over allocated. He will be allocated 16 hours. This is a very normal scenario in schedule. If you prepare a schedule, you will see various resources have been overloaded by 1 hour, 2 hour, or 100%, or 20%, even 200%. What we need to do, we need to label the resources. There are tricks, techniques which are provided in such tools which help us to remove this over allocation and put this into the schedule. When we do resource labeling and some resources are over allocated, then what happens? The project duration normally increases because this extra time doesn't go anywhere but it expands horizontally. So project actually finish little later. Then we have to look at the things that how we can reduce the duration of the project without over allocation. Now, there's something called resource smoothing also. In resource smoothing, we'll see, in fact, we plan in such a way that no resource over allocation happens. So whatever the resources are available, within that resources, looking at their availability, we plan our project, and that is called resource smoothing. Many times adjusting this over allocation within the available float in the project can also be resource smoothing. There are some simulation techniques, and simulation what if scenarios are normally simulation technique, and most common simulation technique is Monte Carlo analysis. Now what is the difference between simulation and other techniques? Simulation means we try to prepare 5 schedules using 5 different ways. Yes, you want to say something?
Yes. Can you explain it again, that resource leveling?
Yeah.
I mean, with some real example.
Yeah, real example are like that.
Like you explained earlier, the train or something, so which is like that way. So you can take any example and explain it so that it will be more
I show you.
understandable.
I show you because I just take one sample project here.
Okay.
And I will just show you what happens. Okay, you're seeing this. This is a simple project. This is a simple schedule, very simple schedule done in one of the classes which I normally do. Like this wall, is you see a red human icon, right?
Right.
It shows that the resource allocated to this activity is over allocated. One of the resources. It can be all also.
Okay.
Flooring also have a over allocation. Now, how do you see over allocation? I'll show you this way. Look at this. It shows this. This is showing over allocation. A site supervisor is allocated to flooring, at the same time is allocated to plastering.
Plastering. Okay.
Same is mason. So this is an over allocation, because one person cannot work at two places.
Right.
I need to label it. So there are some method which is in Microsoft project provided. So I go here in the resource. I shall label the resource. So I selected a resource and I'm saying label this resource. There are various methods. I'm giving you the simplest method just because of my idea is to show you what is labeling. So when I click on this, it is not being done actually. So I have to select both of them and say label the resource. Still it is over allocation.
So you mean to say in simplest ways we have to adjust that one and might be
allocation, because the person is having 8 hours in a day. You cannot work 16 hours a day. So
right.
your work will not finish.
Right. So for example, if the over allocation is in critical path, what should we do?
No, either it is critical path or not, you have to remove it, because the work will not happen. After removing the work, the activity can come on the critical path.
Okay. Okay.
Because see, what we are doing, we are putting this person on the both the places. He can do either plastering or flooring.
Right.
So either I have to bring another supervisor or I have to give it to somebody else. So I click on this, I say reassign it to, let's say, engineer, site engineer. So here I have to see why it is still coming. It may be possible that they may be coming on Saturday, Sunday, so it may be showing over allocation. There is a possibility because we keep doing a lot of things during our course. This is the reason actually. This is a weekend, and they are continuing working on it, and therefore it is showing over allocation. But this is a manageable over allocation because we know we have called them and they can work. But in a day, the person will not work 16 hours at least continuously for a couple of days. The idea of over allocation is this.
Okay.
Okay. Now it comes to simulation. Simulation is a common default. I think you need to mute yourself. The simulation is something which we are trying to do this scheduling in multiple ways, by changing dependencies, by adding some alternative methods of doing the same work. So simulation is very time consuming job because it happens through because we prepare the complete schedule in different manner and try to see which schedule will be better for us. A couple of things which it will help us to understand that it tells us the probability of completing the project on a specific date. So you prepared 5 schedule, and out of 5, 3 times you see the project is getting finished between 5 and 5.5 months. So that means there's a major probability that the project will finish in 5 and 5.5 months. Similarly in a specific cost. So out of 5, if the 3 schedules were talking about about some cost, then maybe we are finishing in this cost. It will also talk about that what is the criticality index of an activity. What is criticality index? That means how critical the activity is. So out of 5 schedule, 4 schedule an activity was on critical path. That means the criticality index of this activity is very high. The possibility some activities are on critical path on all the 5 schedule. Then the criticality of index of that activity is very high. So these are the few things which simulation will tell us, but simulation are time consuming because we are preparing multiple schedule for the same project. So they are very time consuming process. Leads and lag we have understand. Now a situation can happen that we want to complete our project in 6 months, but it is completing in when we prepare the schedule, the duration come out to be 7 months. So then we need to reduce it to 6 months. Sometimes it is possible, sometimes it is not possible. So how we attempt to do this is there are 2 methods. One is called crashing, another called is fast tracking. What is crashing? Crashing means adding resources to reduce the activity duration on the critical path. So first you identify the critical path, because critical path is deciding the project duration. Therefore, activity on critical path need to be acted upon, not other places. Because if you reduce the duration of the activity on critical path, only then the project duration will be reduced. So you look at the activities where by adding resources you can reduce the duration. If a work of 10 days, 2 people are doing, if you add a third 2 more people, maybe 4 people, it can complete in 5-6 days, right? So this is what it is. So we look at the critical path, we look at the availability of the resources, and then we identify, we look at the duration of the total duration of the task. We also see how early in the schedule, how later in the schedule. So there are a couple of things in the picture is the couple of things which are normally decided on the critical path. First of all, second thing, availability of the resources. Third thing, we look at the big duration task. So if a task has 10 days and the task is of 20 days, so definitely if I add resources on a 20 days task, I have more opportunity to reduce the project, right, than the 10 days. So I look at this. I also look at this, that earliest the better. So do at the earliest. Now the thing is that which one to use in out of these 4, we need to create a balance. Look at the situation. There is no thing that you always have to choose earliest one. There is no way that you have to choose every time the biggest, the longest task. It is also not necessary that either of this means you have to balance that. It is early is better in this case, or longest duration is better. Otherwise, it has to be critical path and resources should be available. The repercussion of the crashing is that it increases the cost of the project. Second is fast tracking. As I said that there are discretionary dependency. Discretionary dependency means we can reevaluate them. So maybe earlier we have put A and B in sequence. Now I go and look at this. Can I make A and B together on the parallel? What I will do, the benefit of keeping A and B in sequence will be lost, or the reasons for which I kept A and B in sequence will be compromised. and because of that the risk on the project will increase. So we may be compressing the project, but risk on the project will increase. So in the crashing, cost will increase, in the fast tracking, risk will increase. Now I have to see that I want to reduce full 1 month, and the kind of impact on the risk and cost is coming. Is this acceptable? Is the project really feasible now to execute in 6 months? So we need to continuously see, and if there is no way to complete this in 6 months, we need to go back to the stakeholders and tell that the best feasible is 6 months and 1 week, or 6 months and 2 weeks, not the 6 months. So it will give us a platform where we can check this out, how much cost getting increases, how much risk getting added, is that acceptable, is this feasible, and only that much compression we should do, what is feasible and can be delivered, we can deliver a quality product. So as an outcome of this, we get project schedule, and if all the stakeholders agree on that, or the critical stakeholders agree on that, then you can baseline that schedule, because that's what we're going to execute. You get project calendar. Project calendar means that or resource calendar as well, because the availability of the resource is also important, and identify the working days and shift available, or whatever the timing, etc. the people are available, or the office is working. That is project calendar. Now talk about controlling schedule. Controlling schedule is nothing different than what we have done as of now. Controlling schedule means doing all these things on a regular basis, and because it's a controlling process, we need to measure the plan versus actual, and then take corrective and preventive actions. If there are variance, it will make us to re-estimate in some places, adjust some lead and lags to adjust the duration of the project, apply some compression techniques possibly. So keep optimizing. What we talk about, what the tools we used in scheduling and developing the schedule, all these tools should be repetitively used during the project, looking at that scenario at that time. That is what controlling schedule is all about. These all tools should be used to reduce the variance, to ensure that the project complete on time, or at least if cannot be happen, then telling the stakeholders well in time. You see, all the tools and techniques are same, and what we get here is the work performance information, that is plan versus actual. Schedule forecast is that how we're going to perform in future, and change request as normal. So these are the same thing. Actually, the tools and techniques are same, except that you need to get the actuals and compare actual against the plan, and then see and collect the variance. And we use EVM, earned value management, which we'll learn in the next chapter. What is this? And then forecasting showcasing not showcasing, but letting people know how we are performing now and how we will perform in future. What is our future strategy? That is called forecast. We use all project management software, resource optimization technique we just discussed, modeling techniques we just discussed, lead and lag, schedule compression. All those tools are same. We'll learn how to do the schedule forecast and how to measure this schedule variance, schedule performance index, etc. So we have to calculate this and also forecast. That we'll learn in the next chapter. Sorry. Any question? None? Okay, so let's move to the cost management. Now we have learned about project management framework. We learned about integration management. We are talking about how to initiate a project, plan it, execute it, monitor and control it, change control, and close the project. Then we get into the various knowledge areas. The subsidiary area normally we say of the project plan. So first we learn about the scope, what need to be done. We just finished that when need to be done, that is the schedule management plan and the time management. And the third thing is the cost management. And normally we say this is the core of the project management, scope, time and cost. And we say it's create a triangle which we call triple constraint triangle. Whatever happened in the project, they at the end of the day impact one of this segment of this triangle. The impact will be either on cost, time or scope. And therefore, once you prepare a schedule like in Microsoft Project or Primavera or some Claret or some, there are other tools also, if you prepare a schedule, because something keep happening in the project, this schedule keep changing. That's why the schedule become one of the most changing artifacts. So let's learn about the third side of this triangle, that is the cost management. The idea is to estimate, budget, and control the projects to complete this within approved budget. So therefore process simple, so it will take little less time. Many things are common also with respect to time management. So plan cost management is about again setting up a cost management system in place. Normally such systems are available in the organization. We need to inherit only. So we inherit whatever is being followed by organization, and if it is not already existing, we can prepare our own. What is important in the cost management plan is something like we have to establish some like level of accuracy, at what level we will go. Normally 2 digit of the, because we are talking about currency, it goes maximum to 2 digits. Many times it is not 2 digit. That is decided in the cost management plan, or your organization normally decides. The unit of measure, how you going to define the efforts and the cost. So maybe which is the currency which you're going to use. Your accounting section your accounting section will tell you some various type of cost centers. They are normally called control accounts, where you control the cost of the project. So if there is a project which includes 3-4 functions, maybe every function has a separate cost center, and the in hierarchy in the WBS pertaining to these different functions may be controlled at a different level, and that is what we call control accounts. You saw in a WBS we talk about some establishing control account. We will see here as well. And then we decide, like in the schedule, we also decide here that how much threshold, what is the threshold, how much variation is acceptable, how much variance is acceptable, how much cost variance, less or more, is acceptable. So we also define rules of the performance measurement, control points in WBS, establish unvalue management for controlling the cost as well as schedule, decide on the reporting format. So first thing is first estimate the cost. And if you see here, estimate the cost, they all are, we have already studied in time management. I will give some, and we'll talk about cost of quality in the quality the next chapter. And I will mainly talk about reserve analysis and vendor bid analysis here to understand what these methods are. What we get out of this is a cost of each activity. That is the aim of this process. Before we proceed, let's look at what kind of estimates are possible. So there is one thing called rough order of magnitude. Normally it happens when we conceptualize a project at a very high level, and these kind of estimates are normally provided with a very little information, so therefore the variation is very high. It's just to conceptualize that maybe how much money may required. So that kind of situation is that, then it is rough order of magnitude. Normally budget estimates are just before the initiating a project, or probably at the time of bidding, or just at the initiating of the project. They are better than rough order of magnitude, so the accuracy is medium, and they vary from -10% to +25%. So this is a guidance, okay? But you remember this because there could be some question on, or this may appear on one of the option in the question. So remember these figures for the exam purpose. And then something called definite estimate, which normally happens when you have done the requirement analysis, you are executed some part of the project, then you know more about projects, and then you estimate the project. It is much more accurate. We talk about direct cost. We are all part of the cost management. So what is direct cost? The cost which is incurred due to requirement of the project. What is indirect cost? Indirect cost is the cost incurred for the project, but not because project has come or project is demanding, but to facilitate the project. You may be incurring part of the cost anyway, even if this project was not existing. So something we normally call is like lighting, the office arrangement, the office premise, anything you use during in the common things you use in the office, tea, coffee, lunch, etc., any subsidy, they all are indirect cost because a factor of that cost goes to every project. So your project will also be a portion of it, but that will be indirect cost. To understand really what is the difference between direct and indirect cost, let's take a training. A training can be either a direct cost, can be an either indirect cost. Your organization keep organizing some trainings, general purpose trainings, which are like generally building the capability of the people. So in that case, it will be an indirect cost because it will be a cost, overhead cost, which will get a factor into your project, but it is not specifically done for your project. But your project, suppose your project you have taken is in a specific area, in a specific domain. Then to make people capable in this particular domain or particular technology, you have a very specific technology in this project. People are not available of this technology. You called a trainer to train these people on this technology because this training is happening because of the need of the project. Therefore, this training will become a direct cost to the project. A variable cost is a cost which we can manage during the project, which we can adjust, we can optimize it, and looking at its performance, we can change it. So like resource cost, we can reduce or increase resources on the project, and the cost will go increase or decrease. Material, the same thing. Material, we can adjust our travel, transport, etc. But the fixed cost is a cost which we incur. After that, whatever we do in the project, this cost is not going to change. Normally, infrastructure costs are part of it. So to start a project, suppose you start a project, you want a project management software. You say, oh, to start this project, we need to have a project management software. So buy a project management software. You have spent 1 lakh rupees on that. Now, because you have spent 1 lakh rupees, even if the project abandoned, project get closed, project goes like over budget, under budget, this 1 lakh is spent on the project and it cannot be changed. Therefore, they are fixed cost. You have purchased some equipment. Now, equipment could be tricky in this case. You have purchased it, then it is a fixed cost. But if you have hired it, if you have hired the equipment, then it is a variable cost because you can get rid of it in time. Clear? To estimate the cost, we use all these methods, especially reserve analysis. As I said in the schedule, in the cost also, we have 2 types of reserves. One is called contingency reserve. Another is called management reserve. Now, what is contingency reserve? To take care of the risk. There will be some risk which we fail to identify. Such risk of materializes, then the management reserve come into picture. So you may not be able to identify all the risks. Whatever risk you have identified, based on the impact of those risks, you can assign a contingency reserve. But management reserve take care of those things about the risk which we fail to identify, or which are so big that it cannot be accommodated in the project, like disaster management. Disaster management kind of risk are normally taken care by management reserve, not by contingency reserve. Cost of quality we'll discuss in the next chapter of the quality, but what I can tell about it, cost of quality means if you have to deliver a project or deliver a quality product, you need to take several measures to keep the quality up to the mark. Whatever the cost we will incur to keep the quality up to the mark is called cost of the quality. It could be a cost of conformance, it could be a cost of non-conformance. Cost of conformance means you are ensuring that the product is delivered of what the product will deliver will be of quality. Now cost of non-conformance means you are checking the product which is completed. Is this matching to the quality or not? If it is not matching, we are repairing it to make it up to the mark. So that is also a cost. So that cost will also come into the cost of quality. So those things, because these things are part of the budget, we need to see that how much cost of the quality in this project and add this into the budget. What about the cost of poor quality? Yes, cost of poor quality is also part of the cost of quality. If your product have defects and you have to repair them because to deliver a quality product, then it is called cost of poor quality, because there's repairing means cost of poor quality. And we, looking at the risk and the project, looking at that what kind of work we are going to do, what capability of the people, we should try to forecast some kind of money may get spent on cost of like on the because of the poor quality also. There could be reasons for the project which may indicate that we may not be able to meet the cost of the quality in the first time itself, and we need to check and repair. Though we need to reduce it as much as possible, because we are not so careful, we are normally careless basically, and that's why we spend a lot on cost. And cost of poor quality is normally higher than the cost of good quality. We normally say cost of non-conformance. Repairing defect is cost of non-conformance. Another type of is the vendor bid analysis. Vendor bid analysis is simple terms you understand like this. Many times it happens in governments. Government has to take up various projects where none of the person in the government has any idea how this project will happen. So how to estimate this? So what they do, they float a tender, they ask for proposal, request for proposal, they send, and ask people to submit their how they're going to perform this project and what bid they have, what is the quote. And they study all the quotation they have received. So by studying all the quotations, they come to know that how this project is supposed to happen now and what should be an appropriate cost for this project. So that is the method which is normally used where we have no clue how this project will be executed. What we get is the activity cost estimate, means the cost estimate of each activity. Basis of the estimate, that on what basis we have done some assumption, constraints, whatever we have in front of us, we should document them as well. Once we have estimated cost, what we need to do is we need to determine the budget. What is budget? Budget is a spending of the estimated cost over a period of time. A time-phased spending of the estimated cost is called budget. So how we prepare budget is like this. We have in the estimate, we have got estimate of all these activities. Then we aggregate them, we call it cost aggregation. So we aggregate them, and this plus this plus this will become cost of this. Similarly, we get cost of this. Similarly here. Now, there is a possibility in this, the control accounts are put at the same level, but in a normal project, they may be at different level, depending upon this work package, depend upon suppose HR, this depend upon some, let's say, purchase department, this is a project department. So we may give different control accounts to this. Normally in the common term they are called cost centers. So we can, when we say that this package will be this deliverable is of this function, let's say civil function. So we have a project which has three parts: mechanical, electric, and civil. Now there will be three departments in the project. So under this I will say some other control account, here some other control account, here some other control, so that I can check on this project how much cost how much cost incurred on the mechanical part, how much on electric part, how much is civil part, and where the variance was maximum or where the variance was least. So this all things are important. Therefore we establish some control accounts in that. We accumulate all this, become project estimate. Then we add the contingency reserve, maybe a percentage of estimate. Some percentage of estimate could be contingency reserve, and adding this contingency in the project will make it cost baseline. Now we add something for the project in the management reserve that may not be so visible to project manager, but could be part of the project budget. But actual project budget is this. Management reserve is beyond the cost baseline which project manager has to track, and we say project budget is actually the what is cost baseline. We do reserve analysis definitely to identify that how much reserve is required, how much management reserve or how much contingency reserve is required in the project. Look at this. This is our cost baseline. This is telling about a cumulative cost over 7 months. So since initiation, the project, the team will be small, right? Then in the second month, the team will increase when the planning process will start, maybe this much. Third month, maybe this, maybe slightly increase, this much. Maybe the fourth month, the majority of the team comes, so it increases significant. Then fifth month, some more people get added. Sixth month, maybe similar, or maybe some less because some lot of work has been done, so it reduces. And seventh month we are closing the project, so it may be reducing the thing. So this line is actually talking about cumulative cost income. So it starts from here. This plus this actually become this, maybe this. This plus this will become like this. This plus this will become like this. This plus this will become like this. Then this, then it will not increase that much. Then it will come like this. So our curve become like this. So this shows the cumulative. So this point actually showing the total budget of the project. We say budget at completion. So the project will complete in this much budget. And it shows till third month this much supposed to spend. Fourth month this much supposed to spend. Fifth month this much supposed to spend. And this way, on a month-on-month basis, we can check we are over budget or under budget. Every month we can check because we know every month how much we supposed to spend. And this comes through when we add the cost in the schedule. Because schedule, the events are planned as per the how we want them to be like executed. Based on that, we get this. So without schedule, you cannot get cost baseline. Now, once this is okay with your stakeholders, what you do, you baseline this. So you get a cost baseline, the authorized budget for the project in which project is supposed to complete. Based on this, you set your funding requirement. In software projects, there is no funding required because they don't have any raw material. But in construction, in the manufacturing, you have to buy several equipment, several raw material, equipments, and other things. Based on that, you decide on this that I need budget, I need some money here, I need some money here, I need some money here, and give this forecast to your account department so that they can release the money when you need it. Is that clear? Project budget with time, phase, spending of the estimated cost is called project budget. Now, in the controlling the cost, we mainly use earned value management. The idea here is the same, to identify every time we are going to, how we're going to deliver the product in the authorized budget. So we need to continuously check what is the variance and how to control it. We use mainly earned value management, forecasting to complete performance index, performance review. This all are part of the earned value management, which I am just going to explain. What you get is the work performance information, that is cost variance, schedule variance, cost performance index, schedule performance index. You do a full cost forecast, that is how much more money you need to complete the project, or in how much budget your project will complete, how much overrun is there, how much underrun is there in future or at the end. So by using earned value, we not only get the status of the current project, of current status of the project, we also be able to forecast the future, how we're going to work. So let's understand what is the earned value management is all about. It based on three things. Only three things to be measured. One is called planned value. Second is called earned value. Third is called actual cost. Understand it this way. You need to do some work. Suppose in 2 months. 1 month, 2 months. Total money is $100, which is equally spread. Okay. This is our plan. Now, if you see, I'm at the 50% of the time. 1 month, after 1 month, it is 2 months. I'm at the first month and measuring the project. Because it is equally distributed, whatever the work is planned, how much is the cost of this work? $50, half of the total, right? This is the value of the work planned, called PV. How much is after 1 month when I am measuring? Actually, project is 1 month like completed. I'm here. So how much was planned? Work worth $50. Worth $50. Suppose I achieve little less. I achieve only 40%. Though I'm in 1 month, I completed 1 month, my achievement is less, which is only 50. We supposed to complete 50%, but that is not what it is. The actual thing is 40%. So that is we call earned value. So how much we earned? We supposed to earn 50%, but we earned 40%. How much is the value of this 40% work? What is the value of this 40% work? $40. Simple. We had $50. This was planned. Because I achieve only 40%. So the value of that work is only $40. But suppose I spend $45. Actually I spent $45. So actual I will say $45. So what is the scenario right now? I planned the project complete for $100. I am in the middle of the project. When I am measuring the progress of the project, it says that this. How much was planned? Because it is 1 month, so it was 50% planned, equally distributed. So whatever the work supposed to complete is suppose of value of $50. What is in the earned value? Everything is seen in the terms of dollars, in terms of money. So whatever you are planning, whatever you are achieving, or whatever you are spending, everything converted into dollar. And then we compare it. So we see in 1 unit. Everything we look into the 1 unit, and that unit is actually money, maybe dollar, rupees, whatever it is. So half work supposed to be done, that is was planned, and that is worth of rupees, worth of $50. We achieve 40%, so that was earned, and 40% of the work is equivalent to $40, and actually we spent $45. That is the figure which is coming from the project manager, that how much we have spent. Right? So we have got all three. This is good enough to calculate all the things in the project. Complete health of the project. Now look at the other definitions. We have a budget at completion, BAC. We saw that it goes like this, and this point is BAC. Estimate at completion, EAC. So I am here, I am a little deviated, and because of this the forecast is this. So this is BAC original, this is new estimate, EAC. I am here. Estimate to complete means up to this place I have already executed, so I have actual cost, but how much I am going to spend from this to this place is ETC. How much I am going to spend in future is ETC. So ETC plus actual cost will become EAC. So from this point onward it is ETC, from this point backward it is actual cost. Now we look at the variance at completion. Variance means this minus this. BAC minus EAC. We're supposed to complete in BAC, but we're going to complete in EAC, and this is the variance. Got it? Some more terms. How are we going to calculate schedule variance? It is simple. EV minus PV. If we minus PV from the earned value, plant value from the earned value, it is schedule variance. If we minus actual cost from the earned value, then actually it is cost variance. If we put a division here instead of minus, it becomes schedule performance index. Schedule performance index, at this rate we are achieving things. CPI, at this rate we are getting returns on our investment. Okay, so what is, if it is equal to 0, we are on schedule. If it is minus, we are behind schedule. If this is plus, we are ahead of schedule. Similarly here, 0 on cost, minus over budget, plus under budget. Here equal to 1, we are on schedule. It is less than 1, behind schedule. Greater than 1, ahead of schedule. Equal to 1, we investing $1 and getting $1 of work done. Less than 1, over budgeted. We invest $1 and got only $90 cents out of it. Means we spend $1, but the work we achieved is equivalent to 90 cents. Greater than 1, under budget. We spend $1, but we get the work done of more than $1, maybe $1, 10 cents. What is TCPI? To CPI, to cost performance index. Means whatever this CPI is, from now onwards, if we have to complete the project on within BAC, at what rate we should go? You all follow cricket? If you all follow cricket, you can understand this way. CPI is a run rate at which you are going. So you are in the second inning in a one-day scenario. You are in the second inning. First inning is already set. That is your budget. So first inning, your opponent has played and they have set a target for you. Now you are moving. CPI is your current run rate. TCPI is your asking run rate. You are not hearing? Bhagesh? Now okay. Let me tell once again. CPI is your current run rate. TCPI is your asking run rate. At what rate I should go so that I complete the project in the same budget. What is ETC? So this is forecast. ETC is also a forecast, estimate to complete. Based on CPI or SPI, I decide that what I have to do. So I have to forecast for EAC and then calculate ETC, or I have to calculate ETC and then calculate EAC. How we calculate EAC? There are different scenarios in which we calculate it differently. The first scenario is I have gone like this. I am here. This was original. This was original, but I am going like either this or this. far beyond what my plan was. Because of that, I have decided to re-estimate my project. So whatever cost has incurred is incurred, you can't reverse it. But from here, you can plan another one. This is the first thing. My estimates were fundamentally wrong. I'm going to re-estimate for remaining project. Whatever is done as of now, it's fine. But for remaining whatever work is done, I'm going to re-estimate. Therefore, AC plus new estimate, that is new ETC, estimate to complete from this to end, is what my new EAC is, estimated completion. At what cost I will finish, right? If my earlier estimate were fundamentally wrong. Second thing, CPI is normally calculated as cumulative CPI. So there is no difference between cumulative CPI and CPI. Okay. I am running at a rate, suppose this, and I will continue running at the same rate. Then this will apply. Means whatever the variance I am seeing, this is the typical way the project getting executed, and continue will get executed in the same way. Means my CPI is not going to change. If my CPI is 0.9, that is less than 1, then I'm continue going that way. So I need to forecast. So I will just divide the BAC with the 0.9 to get the new EAC. If my CPI is 1.1, I will divide BAC from 1.1 to get the new CPI. That will be this scenario that I'm going doing this and then complete this project with less than BAC. Okay, the third thing scenario is this. Means as of now, we were deviating, but from now onwards, whatever is remaining work, that will complete in the estimated thing. So if there are A, B, C, D, 4 activities to be performed, as of now I have completed A, which took 10% more. But what I am forecasting that B, C and D will happen as per estimate. That means as of now the variance is 10% or variance is of $100. It will continue till end. At the end of the project also it will be, the variance will be $100. So AC, whatever we have done now, plus whatever BAC is, whatever is left over, that will happen in its own estimates. So B will happen in its own estimates, C will happen on its own. Means B, C and D will be on track. So whatever variance we have got A will carry forward till the end of the project. That is the third scenario. Fourth scenario is a modified second scenario. Normally it's not used so much. This is because of its complication. Got it? So 1, 3 things. Let me repeat this with the diagram. This is our cost baseline. We are at this point of time measuring the project progress. This is how we are performing so far. We are spending as per the green line. We are achieving as per the red line. So you can, by looking at this, you can see that we are spending more than what we planned for, but achieving less than what we planned for. Ideally, actual and earned both should travel on this line. But that's not happening. We are spending more. We're supposed to be here. We're spending more and achieving less. Right? This is earned value. This is actual cost. This is supposed to be. This is the planned one. The difference between this and this is schedule variance. This is supposed to be here, but it's not here. So difference between this and this. What should be the cost variance? If we have achieved this much, we should spend only this much, not this much. If we have achieved this much, we should spend only this much, but we have spent this much. So that this difference is cost variance. Whatever we have achieved, we are supposed to spend only that much, but we have spent this much. So this difference is cost variance. Look at this example. This is for you to calculate. What this example is saying, a project comprising of 4 modules is to develop. Each module takes 1 month to develop with estimated budget of $5,000 each module. So each module duration 1 month and budget is $5,000. Modules are planned to develop in sequence. So every module is happening in sequence. The status of the project at the end of the 3rd month here. I am here. Is presented below. Status at the end of 3rd month. That is this. The 3rd month is completed. What is the status? Module 1 go as per schedule. It is completed. How much AC is 5,000. 5,000 we have incurred. What about second module? Second module is actually didn't finish here. It finishes here. But as of today, it is completed. But we spent $6,000. Now, the module 3 is supposed to start here, but it started actually here because this is in sequence. And it's completed only this much. How much? Half done. That is 50% complete. So as of now, module 1 is complete, module 2 is complete, module 3 is half completed, 50% completed, and we have spent $3,000. We need to calculate all the things. This is in your booklet available. You need to calculate, you need to identify PV, you need to identify AC, you need to identify EV, and then I think PC. First 4 things you need to identify from the current status, and remaining thing is actually a calculation. Which screen you think I should stop? I should keep you on this or this? You have handouts with you, you can use that as well. So right now it is 7:40. I think it's a right time to have a break. Okay, so let's have a 10 minutes break here. Come back, attempt this exercise. Okay, and then we can carry on with this exercise. Right? So take break, come back and attempt this exercise. $14,000, 5,000 plus 6,000 plus 3,000. That's the cost which is written here. So 5,000, 6,000, 14,000. What about EV? 12,500. Simple. The plant cost of the work completed. So how much work is completed? 2.5. So one work is 5,000. So 2.5 becomes 12,500. Rest is calculation time. BAC, you know the cost of the plant cost of the 4 modules, 20,000. So rest is calculation. What is this? CV EV minus AC. EV minus PV, CPI, EV upon AC, SPI, EV upon PV, ETC. You can calculate EAC or ETC, whatever this means. If nothing is giving, you can see that the way the project is going, the same way the project will continue, because no special condition is given. That means in the same way the project will continue. So not specify anything actually. That will be EAC upon CPI, and this will be EAC minus EAC, and this will be EAC minus AC, right? You can use AC plus BAC minus EV if it is giving that such a change, it was a atypical change, it will not reoccur. But nothing is mentioned. It means we should see that whatever the way the project is going, it will continue the same way. If you have completed, then you can match with this. In this, the ETC formula is little different. We didn't use EAC minus AC, but we have done ETC first and then added AC to get EAC. So there will be some minor difference between the figures. It could be instead of 98, it could be 90 or maybe 100, 400 something. Both the way it is right. Okay. So you have forecast as well as the current status, both schedule and cost. Any confusion related to earned value? Is that clear? Should we move?
I think we can move it. So we have to understand it. I mean, we can read it later and practice it more.
Please proceed.
Okay.
Hello?
Yeah, go ahead. Let's move ahead. Oh, I was on the mute actually. What I'm saying that there are a couple of questions in quiz on EVM. So you take quiz, you will have to apply these formulas there. This is one of the important thing in PMP exam, and normally a couple of questions are there on the exam. So you attempt quiz. If you face any problem, if you have any confusion, we can discuss it on next Saturday. Okay, so we have forecasting and current status both. I think this is the only thing which we need normally talk about. The only thing which more you can do is the trend analysis. Every time you measure, you see that how you are doing, and prepare a line graph, or I think that will be the best, that so that you have the CPI line graph, SV line graph. So you can draw line graph for CV, SV, CPI, SPI. So it will give you that how we are performing over a period of time in the project. So this is what it is. In the cost is mainly on value management, and all these things for performance, project, budget, forecast, all are part of the unwell. Done for cost. Quality also is a very small chapter, only like the cost. It also has only four processes, and the idea is to decide on the quality policy of the project, set out objectives for achieving the achieving the quality, and then ensuring that we are achieving the quality. So basically three processes only: plan quality management, perform quality assurance, and quality control. Before we actually go into the quality management, I just talk about a couple of things which are important. That quality is, lot of research has been done in quality, especially in the manufacturing sector, especially in Japan, and when the auto sector was in boom, and so a lot of work was done on quality. And today's quality related matters, whatever you see are results of that work. So the quality management is implemented through the policies and procedures, quality assurance, quality control activities, and one of the most important thing is the continuous improvement, process improvement. So it is not about one-time job, it is a continuous work to improve. So one-time implementation will not work. We should understand the difference between these very close terms. What is the difference between quality and grade? What is quality? Schedule variance is expected less than 5% and your is 10%. You have a poor quality. It has nothing to do with the grade. You go in the market, you want to buy a car, suppose Maruti car. You can buy VXI, LXI, ZXI. Can you tell me which is the highest grade? Which one is the highest grade? ZXI. You got the, what is grade means? Higher the features, better the grade is. So grade shows richness of the feature. All cars supposed to work perfectly the way they are being delivered to you. So LXI is delivered with less features, but it doesn't mean that it should break down on the road. All the cars, whatever is provided, should function properly. That is quality. And grade depends upon the how many features are there in the product. More features, higher grade; less features, lower grade. However, lower grade should also have good quality and higher grade should also have good quality. Right? What is the difference between quality assurance and quality control? Very right, very right. As the term says, assurance and control. Assurance is a proactive term, control is a reactive term. QC is a reactive approach, QA is a proactive approach, but both are required. When project is in progress, it is QA. Once a deliverable comes, then QC start. When the deliverable is being produced, whatever you do is QA work. Once the deliverable is delivered or produced, completed, then you check the quality, it is QC. So what happens after deliverable is complete is QC. What happens before deliverable is complete is QA. When the deliverable is in progress, whatever activity you take to ensure that the product should be produced rightly are QA activities. You provide trainings, you review the work, all these are QA. Once the deliverable is complete, we go and test it. That is quality control. What is the difference between precision and accuracy? Precision is repeatability, accuracy is closeness to true value. Yeah, I think accuracy is absolutely right. Precision we need a little different. I think precision is the depth of the measurement. So suppose you are expecting some value as 5.5012567. Yeah, so if you get a value, actual value as 5.50, okay, and second value you get 5.653215. Now this is less precise but more accurate because it is close to this. But I don't know after 0 it is 12567 or it is something else. So currently it looks more accurate comparing to this because this is 5.5, this is 5.6. So comparing with this is more accurate. This is less accurate, but this is less precise, this is more precise. Merit metrology point of view. Yeah, no, this is actually the depth of the measurement. Product versus project quality. Schedule variance is a project quality. Defects are product quality. Defect shows the deficiency in the committed feature. Schedule variance talk about the project progress. That is the project quality. Conformance to the requirement versus fitness to use. Now this is very important terms and we should understand this. Conformance to requirement is a quality term, that whatever requirements are told to you, you have delivered exactly as per the requirement. That is called conformance to the requirement. Fitness to use is that if that delivered product actually solve the purpose or not. So what happens if you see between customer and vendor, vendor is normally provided with requirements and he provide the product. Yes, application point of view is fitness. Now, but this person's mind is not meeting a requirement. He has a problem and this problem has to be solved. While for vendor doesn't know this problem, probably may not be knowing. For him, the quality is how close the product is with respect to the requirement. So normally if you see, vendor look conformance to the requirement while the customer mindset is fitness to use. Therefore, we keep suggesting vendor that do not go to the conformance to the requirement, read the mind of the customer, see what problem he is trying to solve, and therefore we write business case. Write business case, why this project is being done. If vendor can understand business case, then he will also look for fitness to use, not just conformance to the requirement. When he finds that requirements provided to him are not fulfilling the fitness to use or not solving the purpose, vendors go back to the customer and say that if with this requirement will not be able to meet the end goal, why not we do ABC? Why not we add R1, R2, R3 requirements so that it solve our purpose? Such suggestion customers normally expect from vendor, because vendor is an expert, not the customer. And such suggestions are normally termed as creative and value add. Customer normally agrees to them faster because it solves the purpose, it makes product more mature, and if you see, it generates work for the vendor because vendor get additional work to do. But most of the cases, vendor is not so connected with this problem. In such case, what happens? He just look for conformance to the requirement. Solving the purpose is not his job. In that case, you deliver product exactly as per the requirement, but you see that customer may still not be happy. If customer often complain that the vendor is not creative, they do not provide like suggestion, they do not give creative, there is no creativity there. Actually, he is not such a champion who can translate the purpose into the requirement, and that's what the problem is, and that gap vendors should fill. Anyway, now here is metric and measurement. Measurement is a verb, metric is a noun. Metric is measured. Schedule variance, cost variance, defects, number of defects, all are metrics. 5%, 10%, 25, they are measurement. Right? One is planning, another is execution, third is control. We must see that the quality should be planned in. Means we should be proactive in implement the quality. The quality should, all quality activities should be involved or should be already be there in the plan. So all quality activities should be planned. We should not wait till the deliverable is produced and then check it is right or wrong. This approach will lead to lot of cost, increase the cost of non-conformance. That is repairing, it will increase the repair cost, and repair cost is definitely much higher than the cost of the proactive work. So ideal scenario, or in fact the real scenario is that when the quality work, quality assurance activities are all planned in the project plan, then we have less efforts required for repairing, because most of the product will be good. Both project management and quality, because quality, a lot of research has been done, so quality management in itself is a subject, and customer satisfaction, prevention over inspection, as I just explained, that idea is not to inspect it, idea is to prevent defects. Management responsibility and continuous improvement. Both quality and project management supports all these topics, and they are aligned with these topics. The cost of the quality, as we discussed in the cost chapter, come from two things. We'll discuss it a little later So in planning the quality, we should take care of a couple of tools or couple of things which we need to understand about planning. The cost benefit analysis. Maybe some people will be wondering what the cost benefit analysis is doing in the quality. It's a cost work. Cost of quality, 7 basic quality tools, which I will explain you a little later at the end. But we have to understand benchmarking, sign of experiment. So there are various tools. What we come out is the quality management plan. Quality management plan is talk about what are the quality assurance activities we need to undertake. Yeah, it is Deming cycle, right. What are the quality assurance activities we need to undertake so that we produce the product first time right, and repairing should go down. We should not focus on repairing or identifying the defects, but it is required. So as an outcome, we get quality matrix, what we are going to measure. A quality improvement plan, a quality checklist, so that we know about the completeness. Project. So first thing is cost benefit analysis. The cost benefit analysis is all about seeing that whatever the quality activities we are taking up and the result of those activities. Okay. So every quality activity needs some kind of expense. Everything is expense. Whatever you do in the project, need human resource or need some equipment, and that costs you. That needs an investment. The benefit you are going to get out of it, and the comparison between this cost and benefit, decide we should take this kind of quality initiative or not. Therefore, before we plan quality, we should see that what kind of results we are going to get and if that will solve our purpose or not. So only those quality activities we undertake which solves our purpose. The second is the cost of quality, and cost of quality is considered from the two ways. One is called cost of conformance. Conformance means aligning to the quality policy or trying to deliver the quality product. So there are two things in this. One is prevention and another is appraisal. So there are two parts of cost of conformance. One is prevention. So like training will improve the quality of the human resource, and therefore the number of defects will be reduced. So it's a prevention, but training need cost. So it's a prevention cost. You bring some equipment which help people to do their job better. It will improve the quality. So all these things, better planning, time to do it right, all these things import the process document, all these things are basically prevention cost. The cost of the preventive activities. Then it comes to review. So our review is not cost of non-conformance. Here also we are trying to ensure that the cost, the product should be of quality. The testing, calibration, or activity to test that the product is developed properly or not, or is being developed properly or not. This is called appraisal. This is not cost of non-conformance. In the testing, when we find defects, then we need to repair it. And this repairing is actually cost of non-conformance. So this defect lead to non-conformance. And to remove this defect, whatever cost we incur is cost of non-conformance. So the cost of non-conformance. Non-conformance means either is detected internally or detected by the customer or by the user. So if our testing team identify this, then it is an internal cost. Our developer or our team identifies that it is internal cost. Internal. right? On the other side, if customers identify this, it becomes an external failure, or user report that there is a problem. Later we find early we find the defect, less costly it is. Later we find the defect, more costly it is. There are 7 basic tools and techniques which are used in all 3 processes, that is planning, that is assurance, and quality control. All these 7 basic tools are used. I will take these 7 tools at the end. Another benchmarking. Benchmarking we use. Benchmarking means benchmarking at the industry level. So at an industry level, many people keep giving that industry is working at this level. Industry is working at this level. The productivity of the industry is this much. Now we compare ourselves with that. That is called benchmarking. That industry in some consulting company has come out with some kind of, after some research, that industry's productivity is this, and our productivity is little less. So we say, okay, comparing to the industry, our productivity is little less. That is called benchmarking. The benchmarking could be at internal also, at the company level also. It could be project level also. It could be group level. At any place you can benchmark. No, benchmarking is not best practices. Benchmarking is the current standard. So you have a various projects in your company. Your quality department goes and identify the productivity from all the projects, and then come out with a common figure that our company work with on this productivity. Now against this you measure your project productivity. Your project productivity can be higher, can be lower than that, or could match to that. So this comparison with the standard is called benchmarking, and against which we are comparing is called benchmark, and comparison against the benchmark is called benchmark. The various tools are used normally. Force field analysis is quite common in manufacturing. So what we come out with the quality management plan, the process improvement plan, which could be a continuous improvement kind of PDCA cycle kind of thing. We come out with the quality metrics, that what measurements we are going to do on this project. A quality checklist. The checklist help reviews. So if you have done a review and you have not ticked the checklist, probably your review is not complete, because there is nobody or very few people who will be able to remember everything they need to review. Therefore, a checklist along with a review helps the completeness of the review. Perform quality assurance. Quality assurance are the activities which are performed during execution to ensure that the product which is being produced correctly. So the focus normally remains to reduce waste. Waste is something activity or some investment or some work which is not adding the value to the product. So our aim is to reduce effort on such activity. The quality assurance also look for increasing the effectiveness and efficiency. all quality management, quality control tools, all 7 quality control tools are used. In addition to this, the quality assurance is mainly done by quality audits and analysis of the process. A change request can be output of it because it will suggest some change based on the audit. It will identify some kind of defect during the production, so it will ask for corrective and preventing measure. So various quality tools are used. The quality audits are very common during when the product is being produced. This is like we can also call them walkthrough, audits, reviews. The idea of reviews, walkthrough or audits is to share best practices, share lesson learned, because this person is common among various projects. He can see that what best practices is happening in this project and can take that best practice to the other project. You can also know that what are the lesson learned of the project, can also share this lesson learned with the other project. Identify gap and the shortcomings in the process what the project is following or in the product being produced, and let the team knows and correct it. The ultimate aim of the cost of quality of the quality assurance activities is to reduce defect in the final product, and therefore reduce the total COQ, cost of quality. So more we can prevent defects, less will be the cost of quality. If we cannot prevent the defects, the cost of quality will increase because the repair cost is much higher than the preventive cost. It will definitely reduce the customer satisfaction as well. So quality assurance also ensure that customer satisfaction is achieved and is increased. Process analysis normally help for continuous improvement. The idea is to always identify the root cause and take action to remove those reasons for any problem. So developing a preventive action plan is what is one of the important aspects of the quality process, of the process analysis. So process analysis should be continuously be done on a regular basis to see that if this process is still catering to our need or not. And this may lead to the change in the product, change in the policy, change in the process, procedures, or change in the product. Then it comes to the quality control. Quality control means your product is developed. So in the execution, the product, your team will develop the product. So as we saw in the execution, that main thing was deliverable, main output was deliverable. So once the team has produced a deliverable, it will go to quality control process, and then it will go to verify scope process. So in quality control, we will check the correctness of the product or deliverable, and in verify scope, we will check the completeness of the scope. So here, that is the project management, that's the quality matrix, quality checklist. They come from the quality management plan. Work performance data come from the execution. Approved. And another thing is that deliverable. So deliverable is coming from the execution. Approved change request also come from the change control system, and the change which is implemented, that is part of the deliverable. what we get is the quality control measurements. A validated change, actually it is not a verified change, actually. Verified or validated change. Very validated change and verified deliverable. So a deliverable is verified means correctness and validated means completeness. Work performance information, actual versus plan, and the change request. I will discuss this little later. One is the statistical sampling. Statistical sampling, if I'm wrong, we are discussing these tools for product. It is also applicable to service. Yes. Project can deliver a service and they are equally applicable to the service. Service is an outcome, is a product of the project. Very much, absolutely. So besides the 7 basic quality tools which I am going to discuss, we use inspection. Inspection is again the audit, walkthrough, review, which can be used to verify the deliverable if it is correctly produced or not. What you get is the quality control measurements. Quality control measurements are against the matrix which we defined in the quality management plan. So quality management plan, we define some matrix. Against that matrix we do measurement and come over here. Here the validated change, the changes which were actually implemented, we check them if they are implemented properly or not. Verified deliverables, that is the deliverables which are produced in the quality control, they are checked if they are correctly done or not. Work performance information is the actual versus plan. And the change request, any corrective or preventive measures or defective. During 3 process, we talk about 7 basic quality tools, and these basic quality tools are these, which are very frequently used, and they are extensively used in manufacturing, but normally now being used in all the projects, whomsoever are more concerned about the quality. So let's see one by one. First is cause and effect diagram. It is also called Ishikawa diagram or fishbone diagram. Why it is called? Because it is invented by Ishikawa and it looks like a fishbone. It is like this. The main purpose of this diagram is to identify the root cause. Like in this example, you see there is a documentation defect. So there is a defect in a documentation. So it is the spine which we are talking about, that we should identify first reason that why this defect in the documentation. It could be individual, it could be environment, because of environment, it could be because of the workplace, it could be because of the project. Then you say if it is individual, then what is in individual? It could be an assumption, it could be a lack of experience, it could be the health is not good, it has a lack of motivation, or attitude is not right. You say if the attitude is not right, then what is that? It could be he considered it is less important, is not care about the self-review, carelessness, is an overconfident. So there is a lean principle. Lean talk about 5S, 5Q. So if you ask question 5 times, you probably reach to the root cause of the problem. So first question we asked, why this document defect? We say individual, environmental, group and workplace. In every this segment we can go further. So second question we ask, why individual? So it could be lack of experience, assumptions, attitude, lack of motivation. Third question we ask, why attitude? What is an attitude? It could be least importance, self-review is not done, carelessness or overconfidence. We can ask further questions. Why overconfidence? So this way we can reach to the root cause of the problem. And that is the main objective of the cause and effect diagram, that is called Ishikawa diagram or fishbone diagram, because it looks like a fishbone diagram. In every segment we can go further. Workplace, what workplace? Could be the monotonous work. Volume is high, so he is not able to cater with or cope up with that. High time pressure. So every segment we can go in deeper and deeper as much we want, or we do not reach to the root cause. So cause and effect diagram mainly talks about how to identify the root cause of the defect, or to identify what factors are there in the project which can lead to some defects. So it used in planning as well as in controlling and insurance. Another is called Pareto chart. The Pareto chart is based on the 80-20 rule. 80-20 rule says that 20% of the root or causes are actually the reason for 80% of the problem. That 20% of things are responsible for your 80% of the problem. So if you focus on these 20%, resolve those issues, your 80% of the problem will be addressed. How to identify is this Pareto chart helps. So what is a Pareto chart? Pareto chart is basically a bar chart, but in a descending order. So we identify that because of A, there are 18 defects. Because of B, there are about 11 defects. Because of C, there are 9 defects. Because of D, there are about say 8 defects or 7 defects. Because of E, there are 5 defects. So what we did, we put these in the descending orders. First 18, then 11, then 9, then 7, then 5. Right? And we sketch this graph. And wherever it goes, we consider it is 100% and then divide into this. We take the 80% mark, put a bar on this, throw a line on it, and then from this we can drop a line on horizontal. These are those 20% which are responsible for your 80% of the problem. If we remove A and B, our 80% of the problems will be reduced. Got it? The third is histogram. Histogram is basically a bar chart which is normally used to compare things. Like this was planned and this was actual. So there is an overrun here, or we are behind schedule. Here we are ahead of schedule. Plan was this, design is. If this work is complete, we are ahead of schedule, or we are underrun. Similarly, histograms is normally used to compare plan versus actual. This is basically a bar chart. This is a control chart. Control chart is very much used to check the trends and see if our process is always capable to produce the quality product. The main quality of the control chart, a main property of the control chart is its randomness. So you are measuring every time or you are producing any product. Every time you produce a product, you take a measurement and plot this on this control chart. So if you see the extreme outer side are specification limits. So this is upper specification limit, this is lower specification limit. Specification limits are means somebody has specified that within this range things are acceptable to me. So when somebody tell me that within this the things are acceptable to me, I keep my control limit little less than this, so that I should keep the things within specified limit and I can take actions when a point crosses the control chart but control limit but does not cross the specification limit. So this is our control limit, upper control limit and lower control limit. These are drawn by me, and then I start plotting this could be anything, number of defects, it could be number of defects. You start plotting this. Every time you measure, you put number of defects here, and this line called mean, the mean of all the measurement as of now. As I said, the main property of control chart is its randomness. So the chart must be absolutely random. Any kind of repetition shows some kind of defect or indicate kind of defect. It may or may not be, but it indicates. It provides a reason to investigate. For example, here you see there are 7 continuous points are on the lower side of the mean. Now if that happens, that 7 continuous points come on one side of the mean, that means the process is out of control. That indicates actually. That means we have to investigate if the machine or the process which we have put into place is not developed any problem. Any point out of control limits indicate that process is out of control. Continuous 7 points, 1, 2, 3, 4, 5, 6, 7, increasing or decreasing, 1, 2, 3, 4, 5, 6, 7. Continuous 7 point increasing or decreasing shows a pattern, therefore indicate that the process might have developed any defect. So we should remember that 7 or more continuous point on one side of the mean shows abnormality. 7 or more continuous point rising or falling shows abnormality. Same pattern or change occurs again and again. For example, this, but this is not an abnormality. But I see here also. Then I see here also. It is showing a repetition. It means it's not absolutely random, and therefore it indicates that the process might be out of control. Continuous points near the center line or control line. So any 7 point hugging this line or this line showing abnormality. Anything which is not random showing some kind of abnormality. This is scatter diagram. I explained something about it. Scatter diagram is also a regression analysis. It helps us to find the relationship between two variables, in this terms x and y. This shows that as x increases, y increases. This shows that as x increases, y decreases. This is showing no relationship. As I said in that time, that if this is size and this is number of defects, it shows as the size increases, project size increases, number of defects actually increase. With this, I can forecast that the project is this size, so many defects I should expect, and I should be ready to fix them. Often used for regression analysis. There is run chart. Run chart is normally a trend analysis over a period of time, how a specific metric is performing. It could be schedule deviation, it could be cost deviation, it could be number of defects, it could be anything else. Productivity. And there is some statistics, which is normally talk about this. Average and this upper control lower. Let me explain this to you. Suppose we take this example. We are producing some boxes and we are weighing those boxes. These are the weight of the boxes, randomly coming with some variations. What is this? This is the variance. This is variance. This is square of standard deviation of each point. You know, variance is equal to the square of standard deviation. The same is here. Mean is mean, I think this divided by n minus 1. So let's look at this. We have a mean, total divided by, okay, number of points is equal to this. So this is mean. Now if you see 5.09, the minus this, a square of this is this. So this is variance and this is total variance. So variance is equal to total variance divided by n minus 1 is equal to the variance of the project. Now what is the standard deviation? Square root of the variance is equal to this. So 0.25. Suppose our control limit is 3 sigma. What is sigma? Sigma is a deviation. 0.25. 3 sigma means 0.25 into 3. Plus minus. Plus minus. So mu, that is the mean, plus minus 3 sigma. So if this is my normal curve, this is mean, my control limit is 3 sigma. So 1, 2, 3 sigma here and 3 sigma. So this is my control limit. Any point fall beyond this will be out of control. So it will range from this to this or this to this. One standard deviation means accuracy of 68.26%. 2 standard deviation means accuracy of 95.5%. If your process complies to 3 standard deviation, your process is complying to 99.73%. If your process is 6 sigma compliance, it means accuracy level is 99.99%. 6 sigma, which is quite popular because we are talking about 9.99%. Now how to check if the process is capable to produce? This shows lower limit minus upper limit minus lower limit upon 6 sigma. That is for 3 sigma. That is 3 here, 3 this side. So it becomes 6 sigma total variation. Okay, so we have in our example we have calculated all this. If the CP is greater than equal to 1, the process is scattered. So our lower limit was this, upper limit was this, sigma was 0.25, CP is equal to this minus this 5.5 into this, and this turned out to be 1. It means whatever the machine which is producing these boxes is capable of producing a 3 sigma compliance, producing a product which will comply to 3 sigma, means its output will be within that 3 plus minus sigma range. And let's complete our quality management. Quality management also. Any question? Okay. See, the thing is that I think most of you have not done all the quizzes. Let me tell you that the real benefit of this workshop cannot be availed or cannot be taken up until unless you attempt those quizzes. So 3 quizzes were added in the last session, 3 quizzes now. You have 6 quizzes. Maybe some of the quizzes you have taken up already. My humble request to all of you is this: please go and take out 3 hours in the 5 days week, any time, and attempt these quizzes. The real learning will happen there only. Otherwise, this workshop will pass on. You take up those quizzes later, you will be having less opportunities to clarify your doubts. Here we have still things coming up. We have 2 more sessions and we can discuss a lot about the challenges or the concepts which are not so clear. But if you will not attempt those quizzes, you will not be able to validate what was actually left, what was not so clear, and we will lose a very good opportunity. So please go back. We have complete 5 days. Please take out 1 hour a day. I think you will be able to complete all the remaining quizzes, and we will have a much more meaningful discussion next week. Okay. So thank you very much being here, and we'll take your quizzes, to all the 6 quizzes, and we'll meet next Friday at 6. No, sorry, next Saturday 6 o'clock. Meanwhile, if you face any problem, you want to get some clarification urgently, or you see, okay, let me know, you can drop a mail to me or you can call me. You are free to do that actually. Okay. So thank you very much. See you next Saturday.